everybody. Welcome to the afternoon talks of the first day of PyCon today. Today we have Adriana talking to us about the little scripts that we often don't even think about and how useful they can be.
Hello, everyone. My name is Adriana, and I'm going to be talking about automating data processing in science. I'm going to tell you about a little program that I wrote recently for work and explain a little bit about why I wrote it and talk a bit about the problem of programming in research. So I work for the UCT eResearch Center that's at the University of Cape Town. It's a new entity which is formed out of ICTS, which is the technical support arm of the university. And this entity it aims to not just be about ICTS stuff, but also to work with other organizations at the university, like the library, to essentially provide a kind of unified form of technical support specifically to researchers. So hardware solutions for like storage of data, data management systems, setting up software for them, and they're also interested in helping researchers with programming tasks. Both by running various kinds of training workshops and also by connecting them up with programmers so that certain things can be automated for them. And that is what I was hired for, and that's what I've currently been doing there. So the first project that I was involved with at the eResearch Center was to automate some data that was being used in tuberculosis drug discovery. There's a particular research unit at the medical faculty where they use a plate reader to do assays of compounds that could potentially have properties used for TB drugs. So a plate reader is a machine which essentially scans a plate full of chemical samples, and it detects various properties about those samples. So, for example, in this case, the plate reader is a kind of matrix of little wells, each of which contains a sample, and the sample will contain both a particular compound being tested in a particular concentration, and also a certain population of bacteria will be introduced into that well. And after some time has elapsed, the plate reader will check what the surviving bacterial population in each well is, and it'll spit that data out. And that data can later be analyzed in various ways, and scientists can use that to determine how effective a particular drug is at killing this bacteria. So this research unit uses a project called CTD Vault, which is a web portal which various biochemists use to store their data, share it with others, and also to perform certain kinds of analyses. So, for example, CTD Vault can produce dose response curves, which take that data about the effectiveness of drugs at various concentrations and plots, graphs which can be used to actually determine like minimum effective dosage and that kind of stuff. So these are pretty cool tools, and I think that's they're very useful. And if you want to read more about this particular research and what's being done at this research unit, you can use the link below, which is cut off and also which you won't remember, but which will be in these slides when I put them up on the internet. So at one end of this process is the plate reader. And the plate reader, the plates that go into this plate reader are 96, have 96 wells. There's 8 rows and 12 columns. This is apparently quite a standard format. And the plate reader spits out the readings in an Excel spreadsheet, fortunately in XLSX format and not XLS. But there's no metadata associated with these readings. It's just a grid of numbers, and the plate reader doesn't know or care which compounds are in which wells. So that metadata is stored in a separate file, which is created by the researcher who uses the plate reader and puts chemicals in it. On the other hand, the format which needs to be imported into CDD is completely different. It's a CSV file which has one row per well, which contains both the data and the metadata together in the one row. And I will, at this point, show you what the files look like, because at the moment this is a bit abstract. So the readings look something like this. The real data has like a header on top which tells you things about the plate reader, but essentially it's a grid of numbers, 8 rows by 12 columns. And the metadata is something that the researcher creates in a file which looks something like this. For each plate, there's a well with the ID of the compound concentration. If there are multiple plates, then the columns are repeated across the file. And the CDD import format looks something like this. So you have the plate name, the well, the compound ID goes here, and then we have like the concentration and the data. So it's all together. So now, if you're a programmer, this is pretty trivial to do. I mean, you have one kind of spreadsheet and you want another kind of spreadsheet, well, you can probably figure that out. This is simple. But it's not so simple if you're not a programmer. So what do you do if you need to get data from the one format into another format? Doing it by hand is pretty much a non-starter. It's extremely error-prone, it'll take forever. So the previous solution, which was being used in this unit, was an Excel macro. And that was about as automated as Excel macros generally are automated, which is to say it's a little bit automated, but not very much. So the researcher would still have to do a lot of manual editing. She would essentially copy and paste one plate at a time, first the data, and then copy and paste the stuff from the metadata file, and then push a button, and the macro would magically produce the one plate's worth of data. And she had to repeat this for every single plate, which is really not very automated at all. So we can do better than this with the script. So the first thing that I realized is that the only thing that varies from in the metadata is the list of compounds to be tested, because everything else is completely standard. The researcher always uses a standard format for the wells. It's always compounds going across in different concentrations with a control at the bottom and concentration controls on the sides, and it's always the same, and it's always the same control substance. The concentration is always the same. It's all identical. So using just a list of compounds, we can generate all of the metadata and match it up with the readings, and it'll just work. And so to make the first script, we decided not to make a GUI or anything complicated, just a simple command line interface, mostly as like a proof of concept that this would work. And as I went along, I introduced various refinements to the initial idea. So that plate map file that I showed you with the metadata, the script also generates that as an intermediate format. So the researcher can generate that plate map file once and then use that later instead of the compounds. It means that in theory, you can use a completely generic layout if you want to, just by providing your own plate map file. The script also generates an HTML version of that metadata layout, so that the researcher can print that out and take it to the lab and use it as a reference for using the plate reader. Because previously she just used like a handwritten grid on a piece of paper. Something which I recently added was also generating an additional file for CDD for registering the compounds, which is a slightly different format, but that's also relatively simple to do if you have the compounds. And I've tried to design the code in a relatively future-proof way. So right now the layout is standard and doesn't change, but later they might decide to do a different kind of assay. So I haven't been terribly consistent, and there are various things which will have to be changed in the future, but I've tried to design it in such a way that it's not going to be completely impossible, very difficult to make adjustments and introduce more variables. And it goes without saying that unit tests are a good idea. So this started off as a very small piece of code, but as I added embellishments, it grew and grew and grew, and it's really helped that I had unit tests from the very beginning, because at every stage, when I added something, I had the security of knowing that I hadn't just broken everything else. What tools did I use? Obviously Python, because this is a Python conference. So Python has a built-in CSV module, which does pretty much anything you might want to do with CSV, or tab-separated files, or any kind of file with a predictable separator. It's very easy to use. Because the files coming out of the plate reader are in XLSX format, we had to do something about that. So I found the OpenPyXL library, which is pretty good for reading Excel spreadsheets. So I haven't fully explored what its limitations are. I know that people have complained that if you have a very complicated Excel, it doesn't preserve all the formatting if you open stuff and save stuff. But these are pretty straightforward files. It's essentially just a CSV file in a different format, and we don't have to save anything to the format. We just save everything as CSV. So it's pretty much met our needs. And I used py.test as the testing framework because I like its simplicity. It doesn't have like a lot of the framework craft that like other test frameworks have, and that I like my test to be as simple and straightforward as possible. So it's just a bunch of plain functions, which I will show you just now. So I'm going to go through some of the code in not too much detail, but okay. So is the font big enough, or should I make it bigger? Can everyone see? Good. Okay. So yeah, CSV for obvious reasons. Sys and OS for like basic functions. Argparse is what I'm using for the arguments. There's apparently a better library called Click, but I didn't know about it when I started writing this. There's, of course, some regular expressions, because regular expressions are the spice of life. There's surprisingly little actual maths in this code, because mostly it treats everything in this, all the cell contents as strings, and just transports them without any editing or messing around with precision into a different kind of spreadsheet. But what I do use math for is calculating the concentrations from just one number, because it's a predictable geometric progression. So instead of, this is so that people can later select different kinds of concentrations, and they have a tidy way of selecting them. And some itertool, helper functions. This I think I use to like sort things in different ways. This is used for the HTML output, and this is another helper function. Okay, so this was written so that you can use it even if you don't have the OpenPyXL installed, just with bare Python, if you only want to work with CSV files. Then there's a bunch of objects at the top, which all follow a design pattern which I quite like, which is if you have an object in your code which is associated with some kind of data storage file, or possibly different ways of creating this object, in your constructor, your constructor just takes neat sanitized variables, and any parsing that you have to do, you put in a class method that you call, which is going to return the clean object at the bottom. So all the messy parsing is in this from file method. And as it turns out, this returns a list of compounds rather than just one, because one file maps to several compounds. And everything else that's mapped to a single list of compounds is also in this object. So for example, there's the method for outputting the registration file for the database is also attached to this. Then this represents one set of raw data from the plate reader. This mostly just has a similar layout. It has a helper function for essentially getting the value of a particular well. This is how I map things later. I could probably do this more tightly with a zip or something, but this works well enough, and performance is not really an issue here. And then the plate map file that I showed you, that's associated with the plate map object, which has many plates, and each plate has many wells. So the well is just like a little data structure mostly. And a plate associates multiple wells and has a name, and it can be read from a file. One plate is associated with one output CTD file, although it's possible that we could just generate one big file with everything, but I was matching what the macro was doing. And lower down, this is some plate HTML, but there's actually just one file produced for the whole plate map, which is in the next object. Okay, so a plate map just collects multiple plates, and this is where the HTML is generated. So there's a whole bunch of like HTML style stuff here as well. And so a plate map can be read from a file, or it can be created from a set of compounds, and it can be output to a CSV file, and it can be output to an HTML file as well. Then the next function is a helper function that I wrote so that I wouldn't have to worry in the rest of the code whether something comes from a CSV file or an X file. So this function essentially creates a generator. So if a file is CSV, it iterates over the CSV rows and yields them. And if it's XLSX file, it does whatever crafty stuff you have to do in that module to get at the actual data, and it iterates over them and it returns them. I think it returns none for blank entries, so there's a little wrapper there to like make it into a blank string. So this helper function I use everywhere throughout the code where I'm parsing stuff from a spreadsheet file, and that means I've done this in one place. I don't have to worry about it again. So if I wanted to add XLS support, I could just edit this function and it would add the support everywhere. That's a helper function for pretty printing tables. These functions are for, this function is for later for sorting file names numerically, because for some reason there wasn't a tidy way of doing it. That's so that the researcher can just specify a directory full of readings instead of specifying them individually, and they'll be sorted in the correct order. So truncation concentration map, those are the functions that create a range of concentrations from a single number. Then layout factory. Layout factory returns currently only one standard layout, but in theory, if there are more layouts, then I could detect from the arguments which layout was wanted and return the right layout function, which is used to construct the plate map from the compounds. So it's relatively straightforward. This function will automatically return however many plates are necessary to use up all the compounds. So if it's 7 fit on one plate, so there's more than 7, it'll create multiple plates. And that's for detecting a name for the whole assay from existing plate map file. And this is some more number sort stuff, I think. This is another helper function which prompts, unless the user has specified that they just want to overwrite files all the time, this prompts them to ask if they want to overwrite a file or not. And again, this is something that I just use in all the functions that write to files. So I only have to check it in one place. And then over here, there are some high-level functions which essentially call out to these functions and provide relatively high-level logic for what to do based on certain arguments. So this one, most of them are relatively straightforward and just pass the data straight through, but some are more complicated, like readings from files, checks to see if the directory is there and sorts the files in the right order and does all that stuff so that you pass a relatively clean list of files into the object methods. And the part which generates the actual CDD files checks to see if you have as many readings as plates, and if you don't, it'll complain. And there's a main function which puts everything together and essentially processes the top level arguments and does whatever you need to do. And then there's the argument parser, which has various arguments that you can pass in. Some of them are currently unused, but if you wanted to, you could override the concentration map or the control concentration map. And that's basically it. And I'll just quickly show you the top of the test file. So this is what py.test tests look like. They're relatively simple. They're just functions. I think that there is some more structure that you can use. You can use sort of more traditional test framework setup, but I just use plain functions. Py.test does clever things for you with a temporary directory, so that, as in this case, if you need to make temporary files and then read them, you can use that functionality to do it, which makes things a lot simpler. And there's basically more of this. Okay, so the results of this project. Using the command line was a bit of a learning curve. The researcher was on a Mac, so everything was already there, and there was a command line, which is cool, but she didn't really use it very often. So she did have a bit of a learning curve with just figuring out how to navigate on the command line, how to figure out what directory she was in, relative paths, absolute paths, and that kind of stuff. But she adapted to it relatively quickly and generally hasn't complained that there's no GUI. But if this tool is adopted more widely and we're going to roll it out to more people, I think I'm definitely going to think about adding like just a simple Tcon to GUI or something. I try to keep the dependencies to a minimum, because when you start using Windows and Mac and whatever else, you don't know what kind of environment you're going to be in. But we have Tcon to everywhere, so that should be relatively simple. So the researcher says that the script saves her almost 2 days a week, which I consider a win. And we're keen to release the code as open source, because the people we wrote it for are quite keen to share it with their collaborators at CDD, because obviously it's a tool which makes it easier to use CDD. And I think we're happy to release our code under open license, so we just need to make sure that there isn't a problem with this, and then we'll probably open the repository. So what is this talk really about? This talk isn't really about using the CSV module to parse spreadsheets, because I'm sure most of you could figure that out. So scientific programming isn't all high-performance computing and doesn't always require extremely specific domain knowledge. Sometimes researchers can have these great tools which do most of their work for them, like 95%, and they're really cool and they're really great, save a lot of time, but there's a gap where you have to get from one tool to the other tool, and because this is a relatively niche domain, sometimes the formats just don't match up. So what do you do? I mean, the data processing can be pretty crucial because you can't progress unless you can, join these tools together. And for a known programmer, this can translate to hours and hours and hours of tedious work, and that's bad because researchers shouldn't waste time doing things that a computer can do for them much better, because that's a waste of human brains. So how do we fix this? In the ideal world, which I wish that we inhabited, everyone would be able to do this. I think that being able to process data using simple high-level tools like shell utilities or Python should be a relatively generic, like computer life sciences skill. But unfortunately, we do not live in that world. Some researchers do have like reasonable coding skills, but some of them don't, and it depends on various things. There are some fields which are not traditionally associated with programming. I mean, in some fields of chemistry, it's pretty much expected that you'll know a bit of Python or Perl or something because you're going to be doing data analysis all the time. But in some fields, this was just not a thing ever. And some researchers, just by virtue of when they graduated, have just slipped through the programming cracks, and they don't know how to do any of this stuff. So there are various initiatives which aim to teach researchers more of this kind of stuff. There's software carpentry, which I'm going to talk about in the next slide. But something else that's universities and other organizations can do is connect programmers to researchers. And as you have seen, a little scripting can go a long way. This is not a very complicated program. It does not require, an advanced degree to write this. Pretty much anyone who is, competent with Python and knows how to use the CSV module could have written this. And a relatively small amount of work for a programmer has saved a massive amount of work for a researcher. And if more researchers use this, that's a lot of time saved. So I think it definitely adds value for institutions to look into just automating more of this stuff. So Software Carpentry, it's an international organization which teaches programming skills to researchers. There have been various workshops in South Africa, Cape Town, Stellenbosch, some further up north as well. And there is a workshop this weekend, and there are still spaces open, so tell your friends. And yeah, that is basically it. Are there any questions? Mike.
Sorry, this has been bothering me through the whole talk. What does CDD stand for?
Collaborative Drug Discovery.
Thank you.
Questions? Any other questions? Yeah.
Great talk. I like the use of Excel. Given that you said the user at the end of the day struggled a bit with the command line, and you're thinking of putting a GUI on like tkinter, I'm surprised you're not looking at just building it with a basic web front end from the start. It can run on almost any platform. It's well known. There are lots of skills around it. Can you expand on that?
Actually, well, now that you mentioned that, well, I said tkinter because it was off the top of my head, but I probably would look at a web framework as well, because it's, my only concern would be difficulty of installation. Like, if it's I mean, you could probably make it so that it still comes down to running a single file and it'll just work, but I'm concerned about difficulty of setting things up and adding more dependencies, anything complicated at all that needs to be set up. Ideally, I want something which is as simple as possible, so that in theory, some researcher who doesn't even know me can get this thing from the web page, put it on their computer, double-click on the thing, and things will happen. And if you need to like start up a server somewhere, maybe a bit complicated, but it's probably possible to make everything still like launch from one file. So it's definitely something I'll consider when I get around to looking at GUI.
Anyone else? Oh.
Sorry, just kind of a follow-up to that question. Would it be something that you could solve by having a central web application where the researcher just uploads the couple of different files and then
Well,
spits
see, the
out
thing is, they already have a central application, and
Okay.
it has a lovely input format which is very sensible, and it's like very open. They just, I think it's unlikely that web portals like this are going to like adapt their code so that they can take like arbitrary output files in arbitrary formats, which is really the problem here.
Yeah.
So, I mean, the CDD basically does like pretty much everything that these researchers need already. It's just getting the data into the correct format for using that tool is currently like a sort of missing step.
Okay, cool. No, that makes sense.
Mm-hmm.
Hang on, hang on.
And I don't know if I'm wrong, but I think what everyone's trying to say is if it's a web application on one server, all the researchers can use it. They don't need to set anything up. They just go to the URL. So if the CDD doesn't want to host it, maybe you can make a subdomain.
Oh yeah, we could. I mean, potentially we could have like a hosted instance where they upload all their stuff and then they select options and things. I mean, it is a possibility. Then we get into who's going to host it, who's going to maintain it. It becomes more complicated for different reasons. Then it becomes complicated for institutional reasons and like whose responsibility is it going to be. In general, unfortunately, these kinds of departments don't want to like run arbitrary server code on like some arbitrary machine. Unfortunately, what often happens is that they already have like some kind of intranet system, and they say, okay, can we make it work with the intranet system? And then maybe the answer is yes, maybe it's no, maybe it's complicated, and whatever you design like that has to be sort of fitted into their existing web resources. But yeah, I mean, I haven't looked in. It is possible that we may end up going with something like this. I haven't really we haven't explored this issue very deeply yet, because essentially now it just exists like this proof of concept thing on like someone's computer.
Well, I have a suggestion, but it's not really in the spirit of a Python conference, I'm afraid. Technically, you could do it using an HTML file, there's a JavaScript library for reading XLSX files. You can use the HTML5 file like upload API. I've seen this done to essentially upload files into the local running JavaScript, like what's running, and do it there. But obviously that's going to be very point and click because they'll just open an HTML file, but not really in the spirit of a Python conference.
Yes, it's a fascinating and horrifying idea, which I will leave to someone else to implement.
Anyone else?
You're talking about expanding this to more researchers.
Well, I'm not sure yet, but theoretically.
Theoretically, but what you've got here basically is a conversion from one specific equipment format to one specific website format. Are you planning on expanding this to more types of equipment, or?
Well, it remains to be seen what demand there is and who else is interested in using it. I was mostly talking about extending it to other researchers who are in the same lab and possibly use the same machine. But there's definitely, so the CDD thing is relatively standard. Seems to be like a relatively popular portal that lots of people use. So like the output side is something which is potentially useful to lots of people. The input side, there's definitely the option of extending this to like different layouts of assays, possibly even entirely different plate readers with different different widths and lengths. So it's possible, hasn't been done yet, but it could happen.
Any more? I've got one.
Mm-hmm.
The software carpentry workshop this
Yes.
week, are there spaces for mentors or trainers or something?
Currently, we have almost as many mentors as we have attendees.
Okay.
But feel free to drop in to help if you want.
Okay. Thanks. If there are no more questions, then thank you very much, Adriana.